So, good afternoon, everyone. So I want to just make sure that everyone is with the program with this desire to learn thing. So we had a quick quiz, and most of you took it. I sent an email to those of you who, for whatever reason, didn't. So just make sure there's going to be one of these every Monday and Wednesday, and it'll say what sections you should be reading, so that I don't have to go over them all. And so most people who took it seem to have done just fine with it. Someone said, should I close the book while I take it? That sounds like the honorable thing to do. But if you keep the book open, no one is going to know. What's important to me is that you read through the book, and so you kind of know the buzzwords, so that when we go into the harder parts during the lecture, that you've done the basics. There was a quick homework assignment, and so that's also going to happen every Monday and Wednesday, so you put that into that Dropbox. So a number of people haven't done that. I may have falsely accused one person of not having done that. I'll look at that later. Sorry about that. So now we're going to have a Dropbox for homework 2, and you're going to have to submit a couple of programs, if I could find the darn thing. This looks different from me. So these two things here, I know it's bacteria font for you. Here, 1.3 and 1.4. Those are very simple programs. You'll know enough in the lab today to be able to do them. And you should just drop them in. And then I'm going to ask you to do what's the first draft for P21 and P26. And when you read through them, at the end of your book, you may well say, I have no idea what I'm supposed to do. And that's fine. All I ask you to do right now is to make a program that can have like a pretty empty body and that compiles. Maybe you could put in one print statement that does something somewhat related. But I want you to get started with having the program outline, with having something in there that you can already do. If you can't get it done, that's great, because then I have achieved my purpose. Now you know a question to ask. So the reason that I make you do these in 2 stages is so that I can ask, that you have opportunities to ask questions. The folks back there, you're going to have to go around and see if you can grab some chairs somewhere, because we're going to do the lab standing up is going to be a challenge. So just submit an outline where it has the basic outline of the program that we're going to be walking over earlier today, and make sure to put that in. So I'm going to try to keep these so that they are all doable, that it's a reasonable amount of work, but it is work that's due every Monday and Wednesday. All right, so, oops, no. I see. Okay. I'm trying to learn French, so I force myself to turn everything into French, so I can't read half of the stuff that's going on. But I will eventually. So it's the hope. So we're not going to look at the first few sections here, but I did want to put up this question. How long does it take to learn the entire Java library? Because I want you to know the answer. And you're going to see later as you go into the documentation that it's an overwhelming library. It is huge, and not a single person knows the whole thing. So when you look at it, don't feel bad. It's life in the third millennium that you can't learn everything. All right, so we're going to go and dissect like the simplest Java program that one could possibly devise. Let's see if I can get this a little bigger. Okay. And so you've seen that in the book, and when you look at the components, what you kind of want to do for the first few weeks of the course is you want to look at this stuff here and just take it as a given. It's just as a standard stuff. You always use the same outline, and there's little point in dissecting it piece by piece. I could tell you what this public and what this static and what this void and what this main does, but I won't. If you're curious, you can read it in the book. You don't really need to know it. Every time that you learn a new programming language, there's a certain amount of routine things that are the container of your program. In Java, it's a little bit more onerous than in some languages. And what you do is you just copy and paste it. It's a little known fact that no human has actually ever written these words. Everyone has copied and pasted from someone else, except for the very first one. Someone must have written it before. So copy and paste it, and the only thing that you need to do when you copy and paste it for your own programs, notice this program here is called Hello Printer, and that name you need to change. So you change this one here to like Face Printer for the homework, for example, or whatever. Otherwise, you leave the outline inside intact, and your stuff goes on inside here. Now, in here, you see that this program has two parts. It has the comment. The comment is any human readable thing. So you could put / I hate computers, and the computer would never know. It doesn't read the comments. And then everything that's not starting out with / is an instruction to the computer. So here, the instruction is to print the message "Hello World." And that's just tradition in computer programming, that some of the first program that one writes has to print this message. We've done it for 50 years like that. And so in Java, I'm showing you the same program. So what's really interesting is, of course, what's around here. If you wanted to have it print "Goodbye, cruel world," you would just change the text in here, and that would be simple enough. If you wanted it to print to a file or somewhere, we don't yet know how to do that. So right now, we're also going to have to pretty much take the system.out.println as a command that just magically makes stuff appear on the console. And we're not going to worry too much about why the syntax is that. There's just one thing I do want to point out, and that is that when you look at the dot here, the way that Java works is it says that everything to the right of the dot, and I'm going to have to unfortunately tell you to the right of this dot here, this thing is called a method. And what's to the left of the dot, to the left of the last dot, is what's called an object. An object is a thing that can do stuff. System.out is an object. A method is something that can be done. And then you see the parentheses after the method, and inside the parentheses are what's called the arguments or parameters. And in chapter 2, we're going to be doing a lot of this, where we're going to getting some objects. We're going to figure out what methods can we call on them, what parameters do we need to feed to those methods. So right now, we're just having this one little thing, and all it can do is print. All right, let's see if I... Okay, that worked. Okay, I don't want any of this. Method call. Okay. These self-checks are actually, it's not worth going through them in class, but read through those at home. When I wrote the self-checks, I tried to make them so that maybe the first one was pretty trivial, but a couple of them should be so that they make you think just a little bit, not too much. So here I'm saying, how do you modify Hello Printer so that it prints hello and world on 2 lines? And that's where, when you think it through, you're going to see the significance of this ln thing. So ln means to print a new line, and then if you do it twice, then you get them on 2 separate lines. All right. So as you read through the book, read through those self checks, and that way you can kind of pace yourself. It is a good idea. So now the book then goes on and talks about how you use an editor and all of that, but I'm just going to show you, and then we're going to later practice it in the lab. Let me get this editor called BlueJ, and you're going to be starting it with an icon. I just forgot to make one for myself. So here it starts up. So let me actually start afresh and just die. And start from absolutely zero. So let's say I want to do the very first homework program, which says print a face. Then I click on new class here, and I'll call it face printer. And then it helpfully gives me an outline of the class face printer. What I do with that outline is as follows. I select the entire thing, and then I delete it, because it's done to match someone else's textbook, and so they use slightly different conventions. I just don't find it very helpful. What I instead like to do is I like to fill in the program from the book. So that would be the hello program. Come on. Okay, this is an inefficient way of doing it. Let me instead locate the programs. You can download. Let me show you how to do that. What? 200, thank you. I was going to say, someone hijacked my site. All right, so Java concepts. You can download the source code for all the sample programs in the book, and you should definitely do that. So go ahead and download these, because that way you don't have to type in so much. And it's a zip file. Yeah. I'm making a movie of all of this, so hopefully this will all show up on YouTube eventually, in case you're missing a step. So now I've saved it. Now let me open it. And I realize I'm using Linux, and you're probably not, so this is all going to look a little different, but it'll keep you flexible. Okay, and it is bigjava.zip. So here it is. So when we go to chapter 1, hello, here's helloprinter.java. So here it is. So now I can copy that, paste it into BlueJ. Now, of course, it's called Hello Printer, and I need to make it face printer. And oops. Now I'm going to click this compile button here, and that's going to translate the Java code into bytecodes, and I'm going to run it. To run it is a little funky. What I have to do is I have to right-click on this class, and I have to pick the main method. So when you right-click, you see what you can do with this thing, and I can call main. And this is something that you're just going to have to click OK. It's going to take us probably 7 or 8 weeks before we even get into what this means. And now it prints out hello world, which is not the most beautiful face I've ever seen, but that's because I didn't change that part of the program yet. So now I could go in here and back into the program code and make it print a face. And that's probably the limit of my artistic ability. So I clicked on compile again. I might as well just close this one here. I right-click on this again, do this thing. And now it still shows the previous printout here, and then it shows the printout of the face. Now, many people find it a little confusing that it shows kind of the whole history of what you've ever printed. And if you like that, you can, first of all, go to Options and Clear, and then it clears it once. But you can also say clear screen at method calls, and that way it should never bother you with this again. So you may want to play with these preferences to see if you like that better. Some people like to have the whole history in there. Some people just like to have it effaced after every run. So that's, in a nutshell, how you use this compiler. It's purposefully simple, and as we'll see in next week, it's also very nice in how it visualizes the objects. So let me now try, actually, let me increase the font size. Options, preferences, font size. That's much better. All right, let me put in a few errors to see what happens when you make an error. So, for example, I could accidentally omit the semicolon here. Now, as it turns out that in Java, it's very picky about you have to put a semicolon after every sentence. And if you don't, let's see what happens. So I'll compile. And now I got an error message here that says semicolon expected. Now that's actually a happy day, because sometimes these error messages are not as easy to understand. So now I can put it back in. And now when I compile, all will be well. See, now it says no syntax errors. Let me make a different error. Let me, for example, misspell main like this. All right, and so now when I compile, the class compiled with no syntax errors, because it is a legal name. And now when you run it, then it's misspelled here. And as it happened, oops, what happened? In BlueJ, this works out okay. When we later try this in NetBeans, the same thing will give us a different and harder to understand error message. So let me go back to main, because that's what it's supposed to be. Let me misspell something here. And now when I compile it, then I get a message that says it cannot find the variable named ouch, because I misspelled it. And so that's kind of needs to give you a clue that you probably misspelled it, because in these early stages of programming, you should probably only have variables that it knows how to find. So let me fix this back to out. Now, those are not very common errors. I mean, who's going to spell this as ouch? But I'll give you one that is perfectly common. If you look at this one here, what's wrong?
The capital.
Yes. So Java is a language that's case sensitive. It's very sensitive to whether a letter is uppercase or lowercase. And so in this case here, let's compile it and see what error message it gives. It says package system does not exist. Now this is one of those error messages that if you're just new to Java, you don't know what's a package and what is a package system. And so these error messages can be very confusing. And at that point, you kind of have to look at this line, and it's best to compare it with some code that you know to be right. Pick some other piece of code, and I like from the book, like the stuff that I had here, and then you kind of carefully have to map out, and now of course it's obvious that it's lowercase versus uppercase. It's not always going to be so obvious when you do it in the lab, which is why we're doing the labs in pairs, so that you have two pairs of eyes to see these kinds of things. So these are called syntax errors, because in one way or another, one violates the rules of the syntax of this language, of the Java language. And you're going to be having a fair number of them just by random bad luck. You don't really know all of the rules of the language yet, so it's very easy to accidentally mess one of them up. Another thing that I often see is with these parentheses. So if you look at it right now, you actually have to look at it a little bit hard to see, there's an opening parenthesis here, and the matching closing parenthesis is not here, and it's obscured by the fact that there is another parenthesis sitting in here that's part of the string. So let's see what error message we get in this case. And now, fortunately, we do get a pretty clear error message. It says closing parenthesis expected, and the cursor is actually on the place where it is expected, so that does give you a fighting chance to figure this out. Oops. Another thing that's often done wrong is over here, the quotes need to balance. When enclosed is anything that you want to print literally inside quotes. So now I've removed one of them, and let's see what we now get. Now it says unclosed string literal. Well, what is a string literal? A string literal is the technical term for a string that's literally taken as it is, meaning a string that you set up in double quotes. And so a better error message might have been missing double quote, but that's what often happens. The people who design these error messages, they are not beginning students anymore, so they kind of forget what a beginning student knows, even though this program was designed for beginning students. So now these are the kind of errors that you will get at a regular basis. This particular program shows only the first error. It only shows one error at a time. A more professional program like NetBeans will show you all the errors that it thinks it can find, which can be quite disheartening. So it often happens that you may be just forgetting one semicolon, and because of that, NetBeans gets very confused and shows you 20 errors. And students have been known to jump out of high buildings when they saw that. So that's why the designers of this program decided to only show you one error message at the time, because it gives you false hope. So what often that happens is you scratch your head, you fix that error message, and then you click on compile, and you think everything is going to go. Not so fast. Then you're going to see the next error message and the next. And I'm just preparing you a little bit for minor frustration, because it just is like that. After a couple of weeks, all of these things become second nature, and you're going to never make those kinds of errors again, and you'll probably forget. I know that because I forgot. When I taught CS40, which is taught before this, they used this marvelous environment called Alice, where you can do these animations in its own programming language. And in that programming language, you drag and drop your statements. You can never make a syntax error. And so people were doing sophisticated programs after 4 weeks of that. And then we moved into something like BlueJ and did Java. And for 2 weeks, we did nothing but fix syntax errors. Semicolons, quotes, braces. And so it really is a bit of a challenge, but we'll get past it. All right, so that's kind of all that you need to know to do some basic programming. Now when you want to print something, and printing is pretty much all that we know how to do at this point, you just put in print statements in here, and they will print something. So, you might get a syntax error once in a while, then you fix it. The other kind of errors are called logic errors. A logic error is if you're supposed to print something or supposed to produce some kind of result, which may be computing a solution for some equations, or in this case just printing a simple picture. You could have a program that compiles and that runs, but it still fails to do the right thing. And I'm giving you such a program here right now. It compiles. No syntax errors. Let me run it. It runs. But it didn't produce the face. That's a logic error. Now, for a logic error, one needs to look at the program and say, well, why didn't it do the right thing? Well, I didn't put anything, right? And so to print the empty string, the string that has nothing in it. And so, in that case, now I have to work harder and start making a face with some actual hair and stuff. Probably not a good idea to make me do this because it's going to look terrible. Okay, I'm going to give up. You guys can do a better face than I can. But so now you would start building it up. So, so the key points here are copy and paste. Don't type stuff in yourself, because when you type stuff in yourself, you're just going to be making lots of silly errors by putting the upper and the lowercase wrong. Find something from the book, from the slides, from the code that you can download. That you can copy and paste. When you type things in, try to make these braces here line up nicely. I believe this guy has a way of doing auto layout. Go right ahead and use auto layout. There's some people who believe that that's bad for you, but I think it's just fine. So that it looks nice and neat and everything lines up nicely. When you have an error, try to fix it until the stuff compiles, and you should be good to go. Any questions about kind of these routine basics of compiling? So the book goes on and tells you to a little bit what goes on behind the scenes. So it says when you compile something, it produces a class file. You may remember reading that. And then the virtual machine actually reads the class file. That's something that we're not really observing here, because the development environment, BlueJ, takes care of all of those details for us. And I'm not going to dig into that right now, because you're not going to run into any grief where that knowledge is really important. It's in the book because some people use a different environment where you do everything with individual commands. So we will do that, or probably in 6 months or so, the first in one of the first 46B labs. And until then, it's not terrifically important. So what's important is that you understand how you put in the Java code and how you execute it in this particular environment. So we're going to just boldly go into the first lab. So when we go into desire to learn, it's in one of these drop boxes. And the drop box is Lab 1 Part A. So there should be URL. Oh, crud. Yes. Okay, so here's the lab URL. Let's visit that. It's the first of our labs, so we need to kind of go over the rules a little bit. Ooh, and I know what I forgot. I'll put that in a minute. All right, I made buddy assignments for you. I'm going to leave those up in a minute so that you can see who your buddy is. Now, for those of you who are still trying to add, we're going to work that out in a minute. So after we go over the labs, I will let you find your buddy, and then you need to reseat yourselves and do the lab in pairs. So you work in pairs, and today, one of you, and that's going to be the first one in this list here, is the scribe. It's the job of the scribe to open whatever you use for keeping notes, a document or a text editor window, whatever, and you just type in the answers to the questions as they appear in the lab. And so the questions might be, some of them have no questions. In this case, you don't really have to write anything. But here'll be a question that says, what change did you make? So there's a little question icon. And so then you need to say in plain English, what change did you make? The other person, the one who's in the second column here, where I only put the last names, the other person is the one who runs the development environment, in this case BlueJ. And so that way both of you are busy with something. One of you is busy compiling, the other one is busy writing notes. The scribe is the one who submits the work into Desire to Learn. So after class you need to log into Desire to Learn, or towards the last few minutes, you need to log in and you need to drop that file that you were working on into the Dropbox, just like you did with the homework. That file needs to contain your name and your buddy's name, so that I can later piece it together. And next lecture, meaning on Thursday, we swap. So whoever was the scribe today is the driver the next time, and the other way around. And once in a while, we'll have to interrupt the scheme because Thursday might be a little longer than Tuesday. It doesn't seem to be very fair, but that's how we're going to do it right now. So I want it so that you frequently switch between being the scribe and between being the driver. And the way it should work is that everyone then is going to roughly fill in 50% of these drop boxes, because you're going to be putting in a drop box every second chance. And that way the scoring is going to be simple. So that's kind of how it works. So when you're stuck, you should talk to your buddy. And I realize that right now that I've grouped you together kind of randomly, and your buddy might not know the answer either. If neither of you knows the answer, then try to get my attention, and then I'll help you out. So I will be walking around during the lab to kind of see what difficulties everyone has. And towards the end, we're going to what, till 1:15 today? So around 1 o'clock or so, I will say time is up, and then I will want to discuss some of the things that happened. Now, you might not have gotten done with everything, and that's fine. So you don't have to do it back home. You don't have to complete it at home or anything. It is meant to be done inside class. So if it turns out that lots of people aren't done, then I will make it so that I'll just give you more time for it on Thursday. So do it at a natural pace. Submit what you have. Do submit before you leave this room, so that I can look at it and see how fast everyone is going, and I can pace it accordingly. If you get completely done and you're bored, then that's another problem, and that I'd like to have. And then I'll just come up with some extra stuff next time. But I don't think it's going to happen. So, if you could please find your buddy in some way, and if I could have a show of hands for everyone who is currently adding, who's not yet in the course. Okay, how about we get all the adding people get gathered around me for a second. And so the rest of you could, so everyone who adds, I could have you stand up. And let me count how many. So, find
Where's your partner? They're down the right?
Likes and filts and so, okay. Well, so this is the name of the first one, and then the partner doesn't have the last name. And if you're embarrassed about shouting out a last name like, hey, Lazar, you could look over here and say, John.
Who's Mark Anthony?
All right, we have 1, 2, 3, 4.
Who is he? Cunningham? Elias Clemente? Yeah, Ben?
Yeah, Ben. Right here.
Do you think you can come over here?
We're going to have to do it. Wait until these
We both have our stuff set up, huh? There's room over here, so.
Wait,
Trevor.
Yeah.
Dorian.
Stanford. That's me. Yeah. Yeah. Let's go. I'll have my laptop. Okay. Is there a spot in there? Yeah. Okay.
Did that piece work for you?
So, which one of us is
wait, that's your last name?
My last name's Clemente. My first name's Elias. What's your first name? So I thought it was. Is that how you pronounce your last name? June? So June sounds like the month June, right?
Yeah.
And then you. Okay, cool.
What grade are you?
I'm junior right now. Yeah, but I just basically like transferred my major.
Remember the college?
Huh? I was a biology student, but I hadn't like taken 2 years off, and I just basically decided to.
Our names are listed twice.
Oh, I see. How
are you with Java?
Whoever sits on the left.
How are you with Java? All right, you're the scribe.
I've taken 8
All right, so I was being silly. Everyone's name is listed twice, of course. So the rule is going to be that whoever one sits closer to the window is the scribe, and whoever sits closer to the door is the driver. The scribe, driver, scribe.